So let's look at the 2.4. 2.4, the chain rule. So find today's objectives. Find the derivative of a composite function using chain rule. Okay, and find the derivative of function using general power rule, because I'm gonna use a power rule, but it's gonna be a general power rule. Okay, because you're gonna use a chain rule to do the power rule. Okay, simplify the derivative using algebra. Of course, you have to use algebra to simplify everything. Find the derivative of a trigonometric function using chain rule. That's what we're gonna do today. Okay, we have yet to discuss one of the most powerful differentiation rule, which is called chain rule. This is one of the powerful rule differentiation. All right. Next one. For example, compare the functions shown below. Those on the left can be differentiated without the chain rule. Those on the right are best differentiated with the chain rule. So look at the left-hand side. Yes, this one I know how to find the first derivative. So this would be y prime equal to 2x. I know what this equal to y prime equal to what? Cosine x. These are the simple ones I can do right away. All right, those are the derivative of the simple ones. I don't even have to use a chain rule. But now look at to the right. Okay, look at this to the right. Okay, how am I going to, this one is the same as if I rewrite it, this means x squared plus 1 to the 1/2 power. How do I find the derivative of it like that? Remember, we haven't learned this. So I have no idea how to find without learning a chain rule. Same thing here. Maybe this one, I don't know. I know what's the derivative of a sine, which is what cosine, right? But what about the 6x? What's the derivative of a 6x? So I gotta think about that, right? So I need to think about not just one derivative, I need to think about the derivative of other function, like inside of the function. Same thing here. I know how to find the derivative of 3x plus 2, right? I know how to find the derivative of 3x plus 2, but what about this 5? What am I going to do that? Okay, so that is what chain rule means. You know what chain is, right? Chain means you're looping another one to another one. You know what I'm talking about? So just thinking about the chain. I'm going to just draw. So you know what chain means, right? You connect things like that. That's a chain. So you can visually think about chain rule as you taking a derivative of a derivative. You keep taking a derivative. You chain through it. Okay, take a derivative and then take another derivative, take a derivative, take a derivative. You just kind of connecting those chains. So those examples they gave you today. Let's look at the example they gave me. The first example. So I'm still doing a 2.4 chain rule. So the one that they gave me example was this. If they give you this, y equal to, say if they give me this problem, I know how to take derivative of this, right? What is the derivative of that? If I call that as my f, x squared plus 4, what is the derivative of that? 2x, am I right? Okay, so we know that. So I need to take derivative of other one. So what I'm gonna do, okay, you can think of yourself as, I'm gonna put this one as, how about I call this as I'm gonna call this as a u, okay? So let's just call it u. I'm gonna call, so this one, I'm gonna rewrite it as u like that. Okay, I'm gonna rewrite it. I'm doing a u substitution fast. Okay, it's a chain rule. That's why it's called chain rule. Okay, so I'm gonna put that as my u because I know how to take a derivative of x squared plus 4. So u equal to x squared plus 4, and then derivative of that would be 2x. We got that. Now, come back to this problem because we just set u equal to x squared plus 4, and we plus x squared plus 4 with this u, right? And now I'm gonna use a power rule because we learned power rule. Whenever you take a power rule, you need to make sure you write this problem as a power, not the radical. Then I know how to do it. So y prime is equal to 1/2 times 1 times u, 1/2 minus 1, which gives me y prime is equal to 1/2 u to the negative 1/2. Since it's a negative, I need to put that into denominator. Which is same as 2 the what? That's what I have. Am I right? Okay, so now you need to put this all together. So chain rule means, okay, chain rule, okay, I also need to do this. Because this is a composite function, I need to rewrite this one as a u prime here. And let me put that in the u prime everywhere. So whenever you replace, whenever you do u substitution, when you take a derivative of that, since it's a composite function, you will take a derivative like a power rule, regular power rule, but you multiply with the u primes. Okay, now at the last moment, what I'm gonna do, I'm gonna replace u with the regular function. So I have a y prime is equal to, remember this one right here, that's my final project. So I can, that's my final answer. So I put the u square root of x squared plus 4, and then u prime is 2x. So I have x over x squared plus 4. So I'm done. That is called chain rule. So the word say chain, okay? That means I am taking one derivative. This is my first derivative that I'm taking. Right? And what else did I do? I took derivative of which one? That one. I did take a derivative of this one again. So I'm linking, I'm composing my derivatives. So that's why you get this. So let's do another easier problem. I'm going to give you another example. I know you're not quite get it yet, but if I do a couple more problems, it will make sense to you. So now let's look at another chain rule example. If I give you this, okay, I need to find a derivative. So first thing first, just think about stuff that you already know how to do. You know how to do which part? That part, right? So write down that as your u. So u is equal to 3x squared plus 4. And then u prime is 6x. Okay, that's the first step you're going to do. Do the one you know how to do first, which means inside the parentheses. Inside the parentheses, usually you know how to do. And then I'm going to rewrite this problem, right? Which means y is equal to u squared. So I will take a derivative of that, which is 2u times u prime. Does everybody see it, right? So 2 minus 1, right? I can just say y prime is 2u u prime. Now I can just simply put back the ones I know. You know what u is. So my y prime is 2 times my u, which is 3x squared plus 4. What is my u prime? 6x. So if I simplify everything, I get a what? 12x, 3x squared plus 4. I simplify this together. I multiply this together. Like this. Okay? As you see, chain rule is not any different from power rules, okay? In this case, because I'm just doing a power rule twice. I did a power rule inside the parentheses, and then what do you do? And then I replaced whatever inside the parentheses with the u, and then u to the whatever power, so that become another power rule. So it's a linking, it's a power. It's a derivative linking first one to second one. You put them together, you composite together to finish your derivative, finding a first derivative. Does it make sense to you, class? Anybody have a question? Ethan, do you have a question? No? Okay. Does anybody have a question? Again, make sure that if you are here, you need to say I'm here, so I know you are here. Okay, now let me give you another example, and then I want you to do one problem. So if I give this problem, okay, I gave you this problem, then I need to find y prime. Okay, so this part, you know exactly what to do. What's the derivative of x squared? So simply 2x. Okay, now let's look at this part. Sine. What is the derivative of a sine? Oh, I know derivative of sine is what? Cosine. But I know this. Remember, note. And y prime is cosine x. They are just ax. But what do I have here? 4x, isn't it? So you can think of yourself, okay, I'm gonna say u equal to 4x, u prime equal to 4. So this function right here, you need to use a chain rule. So I have cosine 4x times, what do you have to do? U prime, which is what? 4. Just like this one. I didn't write down, I didn't do the u substitution like this, but I want you to just do mentally. Okay, just think about this. I skipped the u part. So if you don't want to skip any part, if you didn't want to skip any step, then you could just do y is equal to 2x. That's an easy part. And you can rewrite it as sine u prime. Excuse me, cosine u and u prime. In the next step, you're going to say y is equal to 2x plus cosine 4x times 4. Usually, it's your primes, excuse me. So usually you put the number in the front, so you have a 4 cosine 4x, and you're done. Is everybody with me? So I gave you a few different examples to try. So I want you to try this problem for me. One, I just did power rule, simply power rule. The second part, I use what? Chain rule. Because I use trigonometry definition, derivative of definition, which is derivative of a sine x is a cosine x. I don't have x, I have 4x. So I replace 4x as a u, and then I found the u prime, which is a 4, and I composite them together here. So derivative of sine is a cosine. I'm using a 4x as a u. So I need to find the derivative of u, which is u prime. I found it right here. So I can just simply what? Substitute it here. Okay, are you following me, class? So this is a chain rule. You need to make sure that you understand how to do a chain rule, because chain rule require you to remember all the things you have learned. Constant rule, power rule, product rule, and quotient rule. Okay, how about I do one more example, a little more complicated example, using a product rule. So if I give you this, all right, this is a complicated problem, but I'm gonna give you one more example and then you guys can do one problem for me. So if I give you this problem, does everybody see this is definitely product rule? Because I see a two function. Here's the first function. And then what? Here's my second function. Okay, so yesterday we like to just call the first function to be f and second function to be what? G. So that's what I'm gonna do. I'm gonna just stay with the same convention we've been using. So I say, okay, my first function, f is equal to x squared plus 4 to the third. Okay, now I'm gonna say, okay, now I have a little more complicated problem because I used to have simple expression, polynomials, and things like that, but now I have that expression to the power. Okay, so I'm gonna say, okay, that means I do need to do u substitution. So I'm gonna call that to be my what? U. I gotta find du, which is 2x. Okay, then you're gonna say, okay, let me rewrite my f. My f is actually u to the what? Third power. So f prime is equal to 3u squared and then what? U prime. Are you following me? So I'm reviewing yesterday's lesson and then combined to today's lesson. All right, so and then I'm gonna say, okay, now then f prime is just simply equal to 3. I plug it in my x, what my u and all that. So I have x squared plus 4 times 2x. That's my f prime. Now I'm gonna do g. My g is equal to sine 4x. And you're gonna tell yourself, okay, I'm gonna do u substitution. In this case, my u. I mean, if you want, you can call it different number, different letter. It doesn't matter. I call it u, but I can call it as a b. So I'm gonna call it b. So I'm gonna call this to be my b. So my b is equal to 4x. Then b prime is equal to 4. So I'm gonna rewrite my g. G is equal to sine b. So g prime is equal to cosine b, b prime. So you're done. So my g prime is equal to cosine 4x times 4. So I find my f, I find my f prime, I find my g, I find my g prime. So now I can just simply plug it into my formula. So y prime means f times g prime plus what? G times f prime. So let's plug it in then. Y prime is equal to f. What is my f? X squared plus 4 to the third power. What is my g prime? This is my g prime right here. So g prime. So if you are confused, I want you to highlight it so you know which one you're really looking for. This is the one you're gonna use. This what you're gonna use. That's the one you're gonna use. This is what you're gonna use. So g prime is, can I put the 4 first? It'll be 4 cosine 4x. Now plus g, which is sine 4x. And then f prime, which is 3. Can I combine these two? Well, I just write down everything, just what it is, and then combine later. All right, so let me clean up a little bit. I just wrote down for now, I'm gonna clean up a little bit. So y prime is equal to, so this is what you need to do. You don't have to, but it's a good practice. Okay, so look at these two expressions. Look at this expression and look at this expression. All right. So those two are connected by plus. So I can bring out the common factor. So what is my common factor that can bring it out? Can somebody tell me what's my common factor that can bring it out? I see x plus 4 here. Yes, that's right. X squared plus 4. I can see over here. So if I bring out the x squared plus 4, okay, that just become a 1. And this become a what then? If I bring a 1 out, and this become what? One number? 2, isn't it? Okay, so I have x plus 4 square 4 times cosine 4x plus over here is what? 6x sine 4x. Then I'm done. So that's the one way you can simplify, or if you want to simplify a different way, that's your answer. Or I can just say y prime is equal to, just simplify this part, which is 4 x squared plus 4 to the third and cosine 4x and plus, then you have a 6x. And this together is 6x, right? 6x. And then I'm going to do x squared plus 4 and then what? Sine 4x. So if you want to do that, that is also fine. Okay, this is also fine. This is or. Okay, make sure you look over this. Just think about it, okay? Think about this problem. What I want you to do, I want you to do this problem by yourself. You can refer to my note right now. For you, okay, write this problem again and do this problem for me by yourself right now. Okay, I will give you about 3 minutes. Okay, I'm gonna set my timer for 3 minutes. I want you to do that for me, and I will call your name, then I want you to show your work to me. So this is what they're calling by du dx. See, they're calling this one right here They were saying, okay, if I have a y prime, I can call it what? dy du times du dx. That's what they're talking about. When I said I changed that into, let me see the problem like here. Okay, when you see this right here, this is what I did. Problem like this. If I give you, say, y is equal to, say, x squared plus 4 to the third power. Okay, then how did you find this problem? They're giving you exact formula. They're saying, okay, replace this as u to the third, and then take a derivative, which is 3 times u to the second times u prime. That's what this is. Okay, when you're looking for derivative, so dy du, du dx, that's what this means right here. This is an example of this. So do not get confused. When they give you a problem, if it's a composite problem, chain rules that you need to use, you're taking a derivative twice. In other words, you're taking a derivative of this and taking a derivative of u itself, which is u prime. So when you get faster with this, you don't even have to write down u separately, because you can just do everything at once. Like, just think about this one. This is a very good example. If I give you y is equal to, say, x squared plus 4 to the third, okay, then you're going to say y prime is equal to, just thinking as this whole thing is my u, right? And you're going to say 3 times x squared plus 4 to the 2 power, because now 3 become a 1 less power. And then you want to say, okay, and then multiply by what's inside, which is 2x. Okay, if you do enough your homework problems, you can do this. Okay, you can just do it without thinking about it. Okay, so everybody understand? So this is, when you get faster, you can just do this without writing down what u is, u substitution is. You can just do it right away, but not right now. So I want to see every steps. Okay, also you can write it down like this is another way you can think of. See, they're giving you example. Say, okay, when you have this problem, okay, you're gonna call this to be whole thing to be your u. And you can rewrite it like this, and then you're gonna say u to the negative 1 power. Okay, now you have this problem. They will say, okay, replace that 2x as your u. And you can rewrite your problem to be like this. So they're giving you a step. How would you do your problem without getting confused? Again, inside of this, that's your u. Then you can rewrite your problem to be u to the 1/2. And over here, this is just something new. I haven't taught this one. I didn't do this example. So if you have this problem, that is the same as y equal to tangent to x to the what power? It's a second power, right? So write down this inside of the parentheses as your u. Then you have this. Okay, when you have a trigonometry functions, when they have a power, write it down right here. It maybe confuses you. If you rewrite it as something to the parentheses to the power, then you know that's a chain rule that you gotta use. Okay, same thing here. Let's look at some examples. Yeah, we already have done this kind of problem, but in case you don't know, that's what they're still talking about. So we already did, we did more complicated than this. This is using a product rule and chain rule, because you have two functions. You can think of f as x squared and g is equal to this. Okay, and then you gotta rewrite that problem. In fact, let's do this problem, and then we can probably finish our lesson after that. Let me do this problem in a notebook. So y is equal to x squared times 1 minus x. So we know this is a product rule. So I'm gonna call it the first function, I'm gonna call it f. And then second function, the second function, I'm gonna call it g. Okay, I gotta use a product rule. So you need to use product rule with chain rule. Okay, so I'm gonna call it my f. It's x squared. This one, I can just simply do 2x. Because this is just a regular power rule. I don't have to do anything anymore. Now let's look at the second part. G is equal to 1 minus x. I'm gonna rewrite it. G is equal to 1 minus x to the 1/2 power. And I'm going to say, I don't know how to do this kind of problem. So I need to do u substitution. So I'm going to call that to be my u. So my u is equal to 1 minus x. U prime is equal to 1. It's a constant rule, which is 0. Negative x is just negative 1. Then I can find my g prime. So g is equal to u to the 1/2. Then g prime is equal to 1/2 times u, 1 minus 1/2, which is 1/2 times u to the, excuse me. I need to add u prime, right? U prime. So I have a g prime is equal to u prime over u to the u 1/2, which is just u prime over u squared over u. And I'm almost done. So my g prime is equal to my u is 1 minus x. Excuse me, u prime is just the 1. And u is 1 minus x. Okay, that's what I have. Now, I need to take derivative of that. So y prime is equal to f times g prime plus g times f prime. So I will just plug it in whatever f and whatever g is. My f is right here, x squared. What's my g prime? G prime is this. Okay. Plus my g right here. G prime is 2x. So I have a y prime is equal to x squared over 2, 1 minus x plus 2 times 1 minus x. Your book, and then also when you look at the PowerPoints, they simplify even more. But I'm fine with this part right here. They simplify by factoring out the 1 minus x, square root of 1 minus x in the front. You don't have to do that. I'm fine with this part right here. Okay, so I want you to practice this. Okay, I'm done with the 2.4. By the way, you cannot do 2.4 unless you know how to do 2.2, 2.3. So I beg you, do your homework today, 2.1, 2.2, 2.3, and 2.4. So you can ask me questions. And tomorrow we'll finish with chapter 2. Okay, and then you have exam next Tuesday. Also, if you don't have your code, you cannot take your exam. So you need to get your code ASAP. Okay, class, I told you about this since the beginning of the semester. So get your code so you can take your exam next Tuesday. And then also you have something that you need to share with me, you can email me, or you can text me, or you can make a private meeting through the Zoom if you want to. Just let me know so I know how to accommodate you. All right, any questions from today's homework or I mean, today's lesson or any homework that you want me to go over? Is everybody good?
I just had a quick question. Since the book does simplify it to the like the simplest form, um, in our homework, do we have to do that, or can we just do the one that you would do it?
This is fine. What do you stop it right here is fine. And then you say, whatever the reason the Web of Science says you're incorrect and you think you're right, just say, Dr. Harris, can you look over this? And I'll look over it. And I can give you manually credit. Thank you, Stephanie. That's a very good question. Thank you, Stephanie.